Hi, everybody. Welcome to our second screencast. This second screencast is going to be all about finding the surface area of pyramids and cones. So in the last lesson, we were talking about finding surface area of prisms and cylinders. And so today, we're going to talk about pyramids and cones. And so just to do a quick recap on the difference between a prism and a cylinder versus a pyramid or a cone, remember that a prism or a cylinder has two bases that are parallel to each other and congruent shapes, whereas a pyramid just has one face that's a polygon, and then a series of lateral faces that all meet at one point called the vertex. And so there's a couple of things that we're going to talk about as they relate to pyramids and also cones. Right here you only see pyramids, but it's true for both pyramids and cones. So in both a pyramid and a cone, we can talk about the height of the pyramid or cone being the distance from the vertex, from that top point, straight down perpendicular to the base. That's the height, that red line in this pyramid. And then we can also talk about something called the slant height, which is the distance up one side of the pyramid. And so we can look at those two different things. We can look at the height, and then we can also talk about the slant height, which is the height up that side on an angle. And so usually if it's a regular pyramid, we see that there's a right triangle that's formed here. Let me see if I can draw it in for you. So this would be the base of a right triangle. There's the right angle right there at the bottom. And so we can use our right triangle relationships to talk about the relationship between the slant height and the height if we know the distance from one side of the pyramid to the other. And we'll talk a little bit more about that in a minute. But so again, the base of our pyramid is a polygon and the faces are triangles, and the slant height is the height of that lateral face up the side. So if we're looking at this regular pyramid here, this is a square pyramid. It has a height of 15 centimeters. So from the vertex straight down to the bottom is 15 centimeters. They also tell us that the base edge, so this distance from one side of the square to the other side of the square, from one corner to the other, is 16 centimeters. And they're asking us to find the area of each lateral face, meaning each one of these triangles. We're trying to find the area of each one of those triangles that are the faces of this pyramid. So in order to do that, we need to figure out, like if we imagine just taking one of those triangles out of the pyramid, we could figure out what the distance is, what this slant height distance is, using this right triangle. And if you look down below here, they've pulled it out for you, and you can see that there's that 15 centimeters is the height. This distance here, 1/2 b, is half of that base length. And then we can use the fact that this is a right triangle to find the slant height using Pythagorean theorem. And so you'll see here on the left that they go through, they do the Pythagorean theorem, they solve for the slant height, which is abbreviated with that little L, and they find that the slant height is 17. And so then, using that slant height, we can find the area of each triangular face of that pyramid by just saying that the area of a triangle is 1/2 base times height. In this case, it's the slant height. So it's 1/2 16 times 17, which is 136 square centimeters. So using that, we could find the surface area of the whole pyramid. And so in addition to knowing the area of one of the triangles, we also need to know the area of the base, right? So we know that the base is just a square, so the area of that square is just 16 times 16, or 256 centimeters squared. And then we're just going to add up all of the areas to get the total surface area of that pyramid. So 136 was the area of one of the triangles, one of the lateral triangles. So 136 times 4 is all of them together, plus 256, which is the base, would give us a total area, total surface area for that pyramid of 800 centimeters squared. And so here's the theorem that goes along with that. I think sometimes these theorems can make the formula seem more complicated than they really are. If you think about finding the area of the base, a square or a rectangle or a triangle, and then think about finding the areas of those triangular lateral faces and just adding them all up, that can be helpful. Or if you like having a formula like this, then you can use this too. But it's basically the same thing. In terms of finding the area or the surface area of a cone, it's really similar in terms of like the methodology. It's just a little bit different because now we're dealing with something that's circular. So if we think about a cone and the anatomy of a cone, again, we can talk about the distance from the vertex of the cone down to the base of the cone being the height. And then again, we can talk about the slant height being that length along the side here from the vertex to the outer edge of the cone. And again, you'll see that there's that right triangle that's formed between the height, the radius of the circle, and the slant height. So we're going to be able to use that right triangle to help us as we think about the area of this, the surface area of the cone. So if you look down below here, it shows you what a cone would look like if we unfolded it, the net of a cone. And so you can see that the net of a cone would be the circular base, and then this sort of, not semicircular, but it's a sector of a circle where the radius of that sector is the slant height, and then the distance around is the circumference, or 2 pi times the radius. So if we think about how can we think about the area of this sector, if you look over here on the side, just like we did when we were finding areas of sectors before, we have to set up a ratio between the area of the sector and the area of the circle, and the arc length and the circumference of the circle. And if we go through all of that and we solve, ultimately we'll see that the area of the sector is just pi r times the slant height. And so that's something that you're going to want to write down and remember, because it's something that's going to be useful to you as we go through finding all these surface areas. And so again, here you'll see the theorem for finding the surface area of a right cone. Again, it's just the base plus the lateral area, which ends up being the area of the base is pi r squared, it's a circle, plus what we were just looking at, the lateral area, the area of that top part of the cone, is pi r times the slant height. So let's try a couple problems like that. So if you look at this one says, what is the surface area of the right cone? The answers here are in terms of pi. So if you want to just pause for a minute and look at it and give it a shot, go ahead and do that, and then we'll take a look at this answer down below. So then, if you look down here, the surface area we know is equal to pi r squared plus pi r L. The radius of the circle is 6. The slant height of the circle is 10. I used Pythagorean theorem, so 6 squared plus 8 squared was equal to that L squared. I took the square root to find L. I found that L was 10, so that's where this 10 came from. And then I just left everything in terms of pi because that's how these multiple choice answers were given. And I found that the base area plus that lateral area was equal to 96 pi meters squared, which would be B. So let's look at a couple more. So here's a few more questions. There are 3 of them. So I'd like you to pause here and try to do these 3 on your own, and then we'll go through and look at the answers on the next slide. So as you look at that first problem, the traffic cone problem, again, they gave the height of the cone and the radius. And so you have to go through and find that slant height, L. And so you'll see over here, I did that. It's Pythagorean theorem to find L. And then I can find the lateral area, which is all they were asking for in this case. The lateral area, remember, is the surface area without the base. And so the lateral area in this case is just pi r times that slant height. So when I plug everything in, I find that the lateral area is 338.4 inches square. For the next one, they were also asking for the lateral area for number 3. So I had to find the slant height again using Pythagorean theorem. And if you need to go back and look at the question again, you can. But the slant height was 25, and so the lateral area is just pi times the radius times the slant height, and here it is in yards squared. And then that last question asks you to kind of put it all together and find the total surface area of the cone. So you also had to include the base here plus the lateral area that we found up above. And so remember that the area of the base is just the area of the circle. So it's pi times the radius squared plus that lateral area. And when I add them all up, I get that it's equal to 1,885 yards squared. So there's a bunch of questions for you guys to try in your textbook. And if you have any questions, please let me know.